All right, here we go. Question 17 from our Precalculus homework number 2 in MyLab Math. We've got a word problem. It says the price P in dollars and the quantity X sold of a certain product satisfy the demand equation that I have rewritten over here in my window. They want us to answer parts A through G. All right, so this is going to be another multi-part problem. Part A wants us to find a function for the revenue. And here it says, remember that the revenue is X times P, which again I have rewritten over here in the window. Notice that they want our function notation to be R of P. So that means we want the revenue function in terms of P, which means we're going to have to replace X with something in terms of P. Luckily, we know what X is from the demand equation. So we're going to replace X with negative 8P plus 400, and that's going to be multiplied by P. Probably should do at least one step of simplification just to distribute the P and get rid of the parentheses. That's going to give me negative 8P squared plus 400P. That should be the answer for the revenue function in terms of P. Negative 8P. Please don't forget to use P instead of X this time. P squared plus 400P. Next, what is the domain of the revenue function? Well, to answer this question, let's put our thinking cap on for just a second. We notice that the coefficient of P squared, which is the value of A, is negative, and that means that we're going to have a parabola that opens down. Probably going to look something like this, if I was guessing, where the x-intercepts will be our values of P, call it P1 and P2, that determine the values that P can be. So once we know these values of P, again, which correspond to the x-intercepts, then we know that our function will have a domain from P1 to P2. And since we're looking for the x-intercepts, that means we need to set y to 0 and solve. All right, so with this quadratic equation, the first thing I'm going to do is divide through by negative 8. And the reason I'm dividing through by negative 8 is just to make the equation easier to solve, making the numbers smaller. Oh, and it also gets the squared term to be positive. The negative 8's cancel. 400 divided by negative 8 is going to give me negative 50. And then the next step would be to factor out the common factor of P. And then we can set each factor equal to 0 and solve. So we see that I wasn't wrong about the estimate of my graph. It is going to go through the origin where P is 0. And for the other factor, if I move the negative 50 over, we see that P is going to be 50. So P is going to have to be bigger than or equal to 0, but less than or equal to 50. That's the range of values for the dollar amounts. Next part, what price P maximizes the revenue? If you're dealing with a quadratic function that makes a parabola, when they want you to maximize or minimize, what they're really asking for is the vertex. And here the P represents the x-coordinate of the vertex. We know that because the function is R of P, where P is in place of the x. Now, fun fact, the x-coordinate of the vertex will always occur halfway between the x-intercepts. And that's what we just found. So what is the value of P halfway between 0 and 50? Well, it's 25. Now the next part, in order to find the maximum revenue, we will need to take the x-coordinate of the vertex, which is our 25, plug it into the revenue function, and calculate the revenue. So that's going to be the same as calculating r of 25. Okay, so that's going to be negative 8 times p squared, which is 25 squared, plus 400p, which is 25. And then using our handy-dandy calculator to calculate the y-coordinate of the vertex. And that is going to give us 5,000. Now, what does that mean? That means $5,000 of revenue, $5,000 of profit. And I said profit because it's positive. Next, part E, how many units are sold at this price? That means at the price of $25, how many things did we sell? Well, if we go back and read the instructions, notice it says, and the quantity X sold. So X represents how many were sold. So that's going to take us all the way back up to our demand equation, where we're going to replace P with $25, and that will give us how many items were sold. A quick calculation on the calculator gives us a value of 200, and inputting that in MyLab Math just to make sure we're correct. And the next part, part F, graph the function. They want me to choose the correct graph. Well, B and C are definite no-nos because these parabolas indicate a parabola that opens up, but since our lead coefficient of the revenue function was negative, it's going to have to open down. So it's either going to be A or D, and I actually stared at this a good while because those graphs are identical. What I noticed, the difference is how they labeled the axis. So what they're checking here when they're asking you to determine which of these are correct, they're asking, do you know how to label these axes? Well, remember I said that P is the x-coordinate, which means that P would have to be the label on the x-axis. The revenue is the y. So the revenue is the y. And so that means that answer choice A is correct based on how the axes are labeled. Part G, what price should the company charge to earn at least $4,032 in revenue? So that means we're going to need to take our revenue function and replace the revenue, replace the y value with the target revenue. So that's going to give us 4,032 equals negative 8p squared plus 400p, and then we're going to need to solve this quadratic equation for p. First step, moving the 4032 over in order to set this equal to 0 is going to make that minus 4,032. And then to simplify this equation, I'm going to divide both sides by negative 8. Now that's going to make the number smaller and easier to work with. It is also going to make the coefficient of p squared positive. So that's going to give us 0 equals p squared minus 50p, and then a negative over a negative makes a positive 4032 divided by 8, 504. Now, once you've reached this point in the equation, you've got several techniques to finish. Remember, to solve a quadratic, you can either factor, you can complete the square, you can use the quadratic formula. I am going to take the electronic approach. Since I have a fantastic calculator that will actually solve quadratics for me, I'm going to go to the menu, Down to the equation/function option, we have a polynomial equation of degree 2, and then I simply need to input the coefficients of the variables. Here we've got 1 for p squared, negative 50 for p, and the constant 504. And then if I hit equals one more time, it's going to tell me that one of my target prices is $36. If I hit equals again, the other target price would be $14. And so then coming over here to the window, please make sure you read it carefully. It says between a minimum of, so we do need to put the lowest price first, and a maximum of the higher price. And that's going to do it for that particular problem. If you have any questions or comments about anything that I covered, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.